Hello friends, how are you all today? Have you ever wondered what are Jacobians and how we can use Jacobians to solve the engineering problems? It's coming up right now. In the next section, we shall see how to calculate the area or the volume by using the change of variable concepts plus the Jacobians. So first, we will see the calculation of area. For which we are going to use the following formula. Let's say the area calculation is a double integration, so we already know that. Over any region R, a function is given, let's say that is f of x comma y. I need dx, dy. The same function can be replaced by a double integral over d, right? I'm going to write the f. The same function f x is actually replaced by the new variable, so I'm going to write the function x as a function of u comma v comma f of x comma y. So the second variable is y, but we replace y as a function of u comma v. Okay, this we write. Then I am supposed to write the determinant of the Jacobian, that is x comma y over u comma v, right? Then I write du dt. So this is the equation. Now you see that the dx dy, they are replaced by du into d. So double integrations range will be, or the area exact region where you are integrating will be replaced. R will be replaced by d. Still it will be a double integration. Now you see that this Jacobian acts like a scaling factor. Whenever you convert your coordinates, it's always expected that there will be a scaling factor coming into picture, right? The area may go up or down, right? May move to left or right, right? Something like that. That's common, right? Just to cancel that, to nullify that, we multiply by the constant that comes after solving the determinant, right, of the Jacobian. All right, so that's what is all about the calculation of area. Very similar to this, now we also can calculate the volume, right? I'll write the equation itself. That is calculation of volume. Right? This can be done easily by using the following formula. That is, we have to have a triple integral over some region R. Now, volume is a 3D quantity, so it has to have three coordinates: x comma y comma z into dx dy dz. This is equal to the same triple integral calculated over another region denoted by d, right? Now I have f of the function x written as u comma v comma w. Now we see we added a new measure, new axis in the new coordinate system, that is w, x. Y is also written in the form of u comma v comma w comma, I write below, this is inside the square bracket itself, comma z of u comma v comma w, I close the square bracket, started over f. Now I need to write a determinant of that Jacobian, which we are writing as x comma y comma z over, this is u comma v comma w, it's the determinant, multiplied by the variables of integration. We have three variables we are going to replace. This is du, dv, into dz. So you can see that both the equations contain the concepts of calculation of either area or the volume, but they use the concepts which we already have studied. The first concept is replacing the x comma y by u comma v. You can see that's happening in both the cases. We replace it u, v, w in the second case. This is the first concept. That's why we studied the concepts of change of the coordinate system. But initially, we discussed that you can go to any coordinate system you want. You can define by anything as per your requirement. Right? And the second one was Jacobian. You can see that the Jacobian will be used in both the cases. These kind of problems are pretty common in the field of communication, coming into the satellite communication or the aerospace engineering, right, etc. Next, we will solve a problem to understand how one can solve the problems based on the calculation of area by changing the variables as well as by using the Jacobians. This is a question. Evaluate double integration r x minus 2y into x value r is it is a parallelogram, and the vertices are 0, 0, 4, 1, 6, 4, 2, 3 by change of variables. So question is very clear. I'm supposed to evaluate a question. The question says that, right, you are supposed to calculate the area. Okay, that's why it is a double integration. Now, okay, let's first solve. Okay, let's first write a diagram to understand what they exactly have. If this is the x and y axis, so say this is x, this is the y axis. So first I need to draw a parallelogram. So the parallelogram starts at 0, 0, and the highest one is 6, 4. So let's say this is 1, 2, looking at the same thing on the y-axis. 4. Okay, 6 comma 4 comes somewhere here. Okay, this is 6 comma 4. Now I need to mark 2 comma 3 is this point, and 4 comma 1 is this point. This is 4 comma 1 is 2 comma 2. Okay, now let's draw the straight lines required from this point to this point, and a straight line connecting this point to this point. Connecting this to this, connecting this. Okay, we got the required parallelogram. Okay, so they are referring the region of integration as the region that is inside this particular parallelogram. Okay, this is what they are calling as the region of integration. So let me denote that by capital R. Now, so whenever such a problem is given, right, it's better if you write some diagram like this for your reference. That will help you a lot. And in the next step, always you try to find out what are the boundaries of your region which is defined. Because I need to change the x and y to new variables such as u comma v, then these boundaries will change, right? The 4 boundaries defining this region will definitely change. They are supposed to be written in terms of u and v instead of x comma y. Okay, so for that reason, I need to first calculate where is the boundary. What are the boundaries in terms of x and y? Then we'll try, can we change the x and y to u and v? Okay, so to identify the boundary, now the boundaries could be of any shape. Like for each of the shapes, for circle, for straight lines, for ellipse, right, etc. We have different forms, right? You need to remember those basics, and then you need to apply to calculate to represent those boundaries in the form of an equation. If it is an ellipse, you will write an equation of ellipse, hyperbola, parabola, circle, etc. Now we have 4 different boundaries. Each of them will be represented by using the equation of straight line. For example, let me write the first point. So I want to calculate the straight line. I will write straight line from 0, 0 to, let us say, 4 comma 1. Correct? I need to, you can use any form for any form of straight line. I prefer using the 2-point form, that is y2 minus y1 divided by x2 minus x1 is equal to y minus y1 divided by x minus x1, right? So x1 y1 0 0, x2 y2 4 comma 1. Okay, we will substitute to this y2 minus y1. So y2 is 1. I write 1 minus 0 divided by x2. x2 is 4. 4 minus 0 is equal to y minus 0 by x minus 0. So this says y is equal to 1 by 4 into x. Y is equal to mx. We got that comment, but I prefer writing it in a different version. So I'll take 4 to the other side as well as x to the other side. That gives minus x plus 4y equals to 0. Okay, this is my question. Okay. So I'll tell you why I'm writing this in this format later. But anyway, I understood that okay, this line has an equation given by. I'll just make note of that in my diagram. So that will help me a lot. Now this is minus x plus 4y equals to 0 is the equation of that. Okay, very similar to this. Now, anyway, we know the steps how to do that now, so we can do it by ourselves. Directly, I will go to the answers. That means the straight line, right, between 2 comma 3. It starts from 2 comma 3 and goes to 6 comma 4. Okay, when we calculate, we get the following, that is minus x plus 4y equals to 10. Okay, that's why I told we shall write it in this form. All right, then from the straight line, that is between 0 0 to 2 comma 3, right? When we solve, we get minus 3x plus 2y equals to 0. All right, then we have the fourth straight line. That is 4 comma 1 to 6 comma 4. This equation comes to be minus 3x plus 2y equals to minus 10. Right, so these are the equations, right? I'll just make note here so that they are useful when we solve the problem later. So on the top equation comes to be minus x plus 4y equals to 10. So the equation of the one which is on the right side comes to be minus 3x plus 2y equals minus 10. And the left side, the equation comes to be minus 3x plus 2y equal to 0. Right. Now, what was our basic objective? Just recall once. We wanted to change our coordinates from x, y to some uv. Right. Whenever I say uv, my integration limits should be defined in terms of u and v. Correct? Now I got a rule saying that if I say something is 0 to 10 and that something is minus x plus 4y. See, I'm converting x plus 4y to u. Minus x plus 4y, I can replace it as u possibly, right? U varies from this to that. Similarly, I get the v varying from minus 10 to 0, where we can call v as minus 3x plus 2. Because you see in this problem, they have not specified what is this exact transformation. Since the exact transformation has not been mentioned here, we are supposed to make our own transformations. We are free to define anything we want, but this is the easiest way whenever they have not defined any specific transformation. All right. Okay. So this is my first target. That's why I told let's write the boundaries first. So now the boundaries have been marked. So as the boundaries have been marked properly, we can define now. So let the transformations B I'm defining, right? The first one is one of the equation that is equal to, you see that is minus x plus 4y. The minus x plus 4y represents the bottom line and the top line. Bottom line was having a value 0, top line was having a value 10. So my limits are 0, less than or equal to u, less than or equal to 10. This is my first transformation. Then I can write the v as, this is minus 3x plus 2y with the values, you see the right hand side has a value minus 10, which is the minimum, less than equal to b, less than or equal to 0. All right. Now, this is the next step. All right. Once this is done, what I want to do, I want to write, right? I want to get my x and y in terms of u and v. Okay. So we got x and y. We need to solve them simultaneously to get the answer. Okay. So let's write down u and v once again. Right. My next objective is, I write here, to find x and y in terms of u and v, right? We need to solve the equation simultaneously, so let me write them first. So I have u is equal to minus x plus 4y, then v equals to minus 3x plus 2y. Okay, these are my equations. So just to cancel the terms out, what I do, I multiply the first with the 3. So this into 3, what do you get? So that is 3u equals to minus 3x plus 12y. Okay, simply subtract. That is v minus 3u equals, anyway this will cancel, this 2 minus 12 is minus 10y. Okay, so I can write, this implies y is equal to, divided by 10 to the other side. Alright, this is 3 by 10 times u minus 1 by 10 times v. This is y. Similarly, what I want to match the v now, so match the y part now. So I write u as it is. So u is equal to minus x plus 4y, but the second v I multiply by 2. So that is 2v equal to minus, there is a 3 already existing. I write minus 3 into 2, so minus 6x plus 22, so 4y. So if you try to subtract now, these two will get cancelled. So this is u minus 2v equals to minus 1 plus 6. Minus 1 plus 6 is plus 5. So that is 5x. Alright, so we got a 5x. So now we can simply get the value of x. Right? This implies x becomes equal to, take 5 to the other side, so this becomes 1 by 5 times u minus 2 by 5 times v. You got this. So x and y we have. Now what do you want to write the Jacobian? Right? So just remember the Jacobian, I want to write j. My answer should be in terms of, right? u and v. So what you can write, j, this is x comma y over u comma v. Its determinant is nothing but, I want to write dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. Its determinant is what I ultimately got. Right. So now let us substitute these values by looking at x and y and differentiating them with respect to u and v respectively. So let's write the values. So dou x by dou u, right? 1 by 5. Dou x by dou v minus 2 by 5. Then we have 3 by 10, and then we have minus 1 by 10. So how to get this? Simply differentiate. If you want dou x by dou u, differentiate this with respect to u. Anyway, v I eliminate, it's not a function, it's 1 by 5, so you write 1. Okay, so you want to differentiate y, differentiate the top one, you get with respect to u, it's 3 by 10, that's why it is 3. In the same fashion, we can calculate further. Now, when you simplify this, what do you get? We get the following values. I will just simplify this. This is equal to, I have 1 by 5 multiplied by minus 1 by 10 minus, you have 3 by 10 into minus 2 by 5. Okay, this comes to be 5 over 50, which is 1 by 10 or 0.1. Okay, now let's go to the equation. That is, if you want to integrate, it's a double integration over given region R, right? The function is, okay, I'll write the function as it is first, according to the equation, f of x comma y dx dy. This has to be replaced by another region denoted by d. I'm supposed to write the same f where x has to be replaced by u comma v comma, the y also has to be replaced by u comma v. Then you write the determinant, that is j x comma y over u comma v, its determinant, into du dv. This is the equation. The equation b, which I wrote at the beginning to do the conversion by changing the coordinates or the variables to calculate the area. Right. So now I write the same thing below. This means it's a double integration over some region R already defined. The the f of xy is given. You can see the question. It says that x minus 2y into dx to dy. This is nothing, right? Now I am supposed to write the d, but you see the d will be defined in terms of the new variable. What is a new variable? One variable is v, one variable is u. So v, if you see the limits of u and v defined, it says v starts from minus 10 to 0, u starts from 0, goes till 10. Then I'm supposed to write this, be careful. I'm writing the same function. That means this function itself will come over here. But x is not going to be present, you will have uv. Y is not going to be present, you have uv. So I should write the x minus y itself over here. But you cannot write x, you have to write in terms of u and v. That's why if you see the previous steps, we actually have represented x equal to and y equal. Right? X equal to something we found, y equal to something that's also we found. Right? So let me show you that part now. So you see here, this is the equation. Wherever you see x, right, you are going to replace it by this. Wherever you see y, you are going to replace this. Okay, y. Right, so this is equal to, I have to write x minus 2y, but what is x? X is nothing but 1 by 5 u minus 2 by 5 v. This is the x, okay, minus 2 times the y is nothing but 3 by 10s of u minus 1 by 10th of v. So this is the x minus 2y in terms of un. Then I need to multiply this with the Jacobian. So Jacobian is 1 by 10. Okay, I write that. Into, you should write the variable du dv. Alright, upon simplification, let's do that. This is, I'll take the 1 by 10 outside. There is a double integration. First variable is v, which is minus 10 to 0. And the inner variable is u, that is 0 to 10. Let's simplify. 1 by 5 u minus 3 by 5 u is minus 2 by 5 u. Okay, then this and this, when we simplify, 2 by 5 and minus 1 by 5, right? So it's a 1 by 5. So this is minus 1 by 5 v du dv. So it's a simplified format now. I'm supposed to integrate this 1 by 1 variable. So first let me do the integration with respect to the inner variable. So that's going to give me, this is equal to 1 by 10. This remains minus 10 to 0 remains. When you do the integration of minus 2 by 5 into u, I'm going to get u square by 2. So 2 will cancel. It is minus u square divided by 5 minus v is a constant. So it is 1 by 5 u into v. Substitution will take place from 0 to 10. I'm left with only one variable, that is d. So this is equal to 1 by 10, right? Integration minus 10 to 0. So substitute u square, u is 10, so 10 square is 100, minus 100 by 5 is minus 20, minus 0, so it's just minus 20. Then the minus part comes. Put u is equal to 10, denominator is 5, cancels with the 10 as 2, so minus 2v. Anyway, other part is 0, so it's minus 2, right? You simply integrate with respect to v. So this is equal to, now this is 1 by 10. Integration of minus 20 is minus 20v. Okay, minus 2v is v square by 2, so 2 cancels, it's just v square. Okay, limits minus 10 to 0. So when you put 0, this is not minus, plus 1 by 10. This is 1 by 10 into, so 20 into 0 is 0, then minus 20 into minus 10 is 200. Okay, it's a positive 200. Then I have minus, put 0, doesn't come, and minus 10 square is plus 100, so there is a minus outside, so you get a 100. Okay, so this is 200 minus 100 is 100. 100 by 10 is 10, is the required area.